Hello, everybody. This is Mr. Bowman. I'm going to be walking you through how to use the area model to multiply 2 by 2 digits. For example, we'll start with an easy one, 12 times 13. The way this, where I'm hoping it gets taught to our kids, would be with uh, manipulatives. So, for example, here I got 12 times 13. And if you want to know what the area model is, when we talk about area model, and I wrote that really bad, so let me write that here. So, I'm going to write the area model. Really, we're just finding the area of a rectangle. We're going to physically use these things to find the area of a rectangle. In this case, my dimensions are 12 by 13. And that's all we're doing. So what the kids need to know is at least to be able to decompose the number, uh, into its tens and its ones. So up here will be the 13. And my left side over here, on the side here will be my 12. And I'm going to do this. Make a copy, bring it down, and rotate it. So these are my dimensions, 12 by 13. And in here is our area of a rectangle. So we start multiplying this by its decomposed parts. So for example, 10 plus 2, 10 plus 3. We ask our kiddos, what is 10 times 10? Hopefully they know it's 100, so they bring the 100 there. 10 times 3 is 30. So I would need 3 tens to fill this in here. Boom, boom, boom. And I'm going to grab 2 of these guys, make a copy. Because over here in the bottom corner, I know that 2 times 10 is 20. And then all I got to do is fill this little corner, which is 2 times 3, which would be 6. 4, 5, 6. And there it is. Now, the only issue that when using manipulatives is sometimes our students will include the dimensions as part of the answer. So always have them remove it, all right, or move them to the side, and then this will be my answer. So this is 12 times 13, which is 100 here, 30, 20. Or they can count by tens, 10, 20, 30, 40, 50, right? And then count the ones would be your 6. So they can do what's called partial products to get their 156. Some kids will see how many tens we have and write it as 100 plus 50 plus 6. And then from there, give me about 156. Either way, we got the right answer. So the error model, it's almost impossible to get the wrong answer of manipulatives. I mean, you're pretty much guaranteed the right answer when you use manipulatives. And then eventually they will move on to, oh, by the way, this is called in our case, it's called the concrete part of learning how to do the mathematics. Since I'm using a virtual manipulative, it is actually concrete and pictorial put together, but we can say it's a concrete part. So when I get here, we can actually have our students draw it out. So we can use this color here. We just go by tens, not by tens, but we're going to count 10. 1, 2, 3, 4, 5, 6, 7, 9, 10. That's my 10. All right. And then 2 more because I'm going to get 12, right? And these are my ones right here, 10 and my ones. Over here now I'm going to draw out the upper dimension, which is going to be 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then my 3 right here. And then all I do is I'm going to fill in the area of the rectangle. And it's look very similar to our virtual manipulatives. If you go into yourself, man, you don't draw very well. No, I don't. But I think we're getting the idea here. I would always get in trouble with the teachers when I would draw. And so there it is right there. And draw your lines coming over here. And this is important that we do this part of the process because later on, our students are going to get this as a test question. And if they're exposed to the pictorial model, they have a better chance of getting the correct answer in the state test. So here I have it again. 100 plus my 5 tenths, which is 50, plus my 6 ones, which is 6. So I'm getting 156. So there we go. Concrete, pictorial, and then we're going to ask for the abstract, which looks like this. Here, we don't have to have 10 or anything like that. Here, the kids just write 10 plus 2 times 10 plus 3. We go 10 times 10 is 100. 10 times 3 is 30. 2 times 10 is 20. 2 times 2 is 6. And we have it again right here. 100 plus 50 plus 6, 156. So this is a pictorial representation. This is considered the abstract representation. And we've done concrete, pictorial, abstract concurrently. So there it is. Ta-da! Easy to do.